Bienvenidos, Ushamdi, and welcome CTS-131 Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Cisco Networking Academy Routing and Switching Essentials version 6 course, and this afternoon's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 6.2.1.7, where we're now going to look at configuring virtual local area networks. In other words, we're going to be moving away from that default configuration that we're comfortable with and that we're very familiar with, which is everything is in VLAN 1, and we're now going to start to provide virtual separation for different network segments. So let's go ahead and dive into the activity here. And let's close this down and get our desktop back here. Unfortunately, it looks like the desktop disappeared on us. And the virtual machine is chugging away. There we go. And desktop. Okay, so here we are. And here's our topology. Now you can see a couple quick notes about the topology. Remember, in previous topologies and in previous activities, everything that you see here would have been in VLAN 1. And by default, we could interconnect these switches, and these did not have to be trunk links. In fact, if everything is in the same VLAN, there's no need to do trunk links here. We can simply just plug connections in between these three switches, and we're just extending the broadcast domain. Now, I'm going to use a couple terms here. I want you to think of a VLAN, a virtual local area network, is a broadcast domain. I'll just put BCASD. Whoops. Is a broadcast domain, is a subnet. That these are all synonymous terms. And so the way that we talk about this is a virtual local area network. We would put everybody in the, let's say, 192.168.10.0/24. And they're all in the same broadcast domain because they're in the same subnet. And what would the broadcast address be in that network? Exactly, it would be 192.168.10.255 because this is the network identifier. That would be our broadcast address because that's the last address in this range. And then the usable addresses would be from .1 to .254, or everything in between 0 and 255. And so a VLAN is a broadcast domain, is a subnet. Definitely remember that, and hopefully it'll make it easier for you to break things up and to understand what's happening when we're creating different VLANs. Now, we have, what do we have? VLAN 10, 20, and 30 on the left, as well as VLAN 10, 20, and 30 on the right, and they've thrown a curveball in here. They've dropped an IP phone into the setup, and Lauren had a question on this earlier in the week, and I actually did some research in the text because I know that they had mentioned it, and I thought for sure I had seen the commands that would be required to do this configuration in the Routing and Switching Essentials version 6 course. And so I looked in the online course on Netacad and the PDF version of the book, and I don't see anywhere where they give you the switch port voice command. And so if that's causing some confusion, I'll be covering that as well as the MLS QoS Trust class of service, and we'll get to that. I believe that's in this activity, and we'll see. Yeah, here it is right here, class of service values. So we'll talk about that because, again, remember the phone, inside the phone or on the back of the phone here, there is a switch port on the phone, and that's what the PC is plugged into. And then there's another network connection or port on the back of the phone that then plugs into the switch. And so the PC comes through the phone, and the phone is going to be using two VLANs here. So there's going to be a voice VLAN, and there's going to be a data VLAN. And so we just simply need to make sure that we accommodate that in our switch configuration right here on our Cisco switch. So again, if everything was in one big VLAN, everything would have the same IP address, right? Or in the same subnet. So it would be 172.17. We'll say 10.0/24, and everybody would be in this subnet. They would all have the same broadcast address, right? Same broadcast domain, and they're all in the same VLAN if this was VLAN 1. But now we're going to be breaking things up. And so when we break things up, here's an interesting way to think about things. If I were to circle these guys here and say, this is the HR department, right? And then we want separation from the HR department because they don't need to know what the engineers are doing, and the engineers don't need to be seeing what the HR team is doing. And last but not least, and let's actually use, we'll go with a purple here. Last but not least, let's say that this is the, what do we got? The finance office. And so this is how, from a virtual networking perspective, we're going to go ahead and create virtual local area networks. In other words, we're taking the physical switch, which by default every port is in the same local area network, and we're going to carve the switch up into multiple VLANs. And we're going to do the same thing on all of these switches. We're going to carve them up into multiple VLANs. So there's one VLAN there, there's another VLAN here, another VLAN here, and the single physical switch will have multiple virtual local area networks. And we just simply do that with a VLAN. All right, so that's a quick review. And I wanted to touch on the phone as well because that does cause some confusion here as we move on. So let's go ahead and we're going to take a look at the default VLAN configuration. So display the current VLANs. We're going to get onto switch 1. And let's enlarge switch 1 a little bit here so we can see a little bit better what the VLAN configuration may look like. So we'll come to the CLI, and we're in user exec as evidenced by the greater than sign. Let's issue the enable command to get to privilege exec. Now, how do we see the VLAN configuration? Well, we can say show VLAN, and this is going to show us a little bit more information than the command show VLAN brief. Right, as you can see, show VLAN brief gives an abbreviated version of the output. And then what is the only VLAN that we have configured where and to which all of the ports are assigned? And that's VLAN 1. Remember, we've got these, and these are legacy here. You're never going to end up using those anymore. They're just left here for legacy reasons, 1002 to 1005. So VLAN 1 is the default, and as you can see, every port is in VLAN 1. So on switch 1, issue the command to display all VLANs configured. We just did that. By default, all interfaces are assigned to VLAN 1, and they are. Now let's verify connectivity between the PCs on the same network. So now notice that each PC can ping the other PC that shares the same network. So 1 and 4, 2 and 5, and 3 and 6. So if I get onto PC 1, we're going to ping 172. Bring that down a little bit. We're going to go ahead and we're going to ping 172.17.10.24, and let's see what happens. Ping 172.17.10.24, and we have connectivity. And let's go the opposite direction this time. We'll ping from PC5 over to PC2. And again, remember, they're on the same network, 172.17.20.22, and we've got connectivity. And now from PC3, and we'll bring this down just a little bit here so we can see a little bit better. Actually, we'll move it over. And we don't want the terminal. Let's ping 172.17.30.26. So all we've done here is we've pinged between each of the PCs in the same network. It says pings to PCs in the other network will fail. Well, let's check that out. If I was to say ping 172.17.10.24, so trying to ping from PC3 to PC4 is not going to work. Those requests are going to time out. Again, we don't have any routing taking place, and they're not in the same broadcast domain. They're not in the same subnet. Now, what benefit will configuring VLANs provide to the current configuration? And the benefit that they're going to provide is that it's going to allow us to segregate the network, right? To provide logical separation, and it could be based on business unit, it could be based on unit function, right? What is the function of this group of individuals? And again, we gave the example of HR, the finance department, and then the engineering group, right? And there could be a management VLAN even. So here's what we're going to do. We're going to create a name VLANs on switch 1. And I believe if I were to take a look, I'm curious here on switch 2. We haven't looked at switch 2, and the reason I'm looking here is I'm wondering if, no, everything is still in VLAN 1. All right, so we may have to do quite a bit of work here. So let's get on to switch 1. And they're asking us to create some VLANs. So how do we do that? Well, we need to get into global config. So we issue the configure terminal command, or conft, and then we're simply going to say VLAN 10, and then we're going to name it. And it's faculty/staff, VLAN 20, and then the name is students, VLAN 30, and the name is guest, default, and then we're going to say VLAN 99, and so this is going to be our management, and native VLAN, and then VLAN 150, and this is going to be our voice VLAN. All right, so we've created all the VLANs required. Now, what happens if I say do show VLAN brief? We see all of the VLANs listed there. Now, none of those VLANs that we've just created has any ports assigned to the individual VLANs, and we'll be doing that coming up shortly here. It looks like we're going to configure switch 2 and switch 3. So we're going to get a lot of work here walking through the process of configuring VLANs. It says verify the VLAN configuration, which command will only display the VLAN name, status, and associated ports on a switch. And there's the name, the VLAN, the name, the status, and the associated port. So it's do show VLAN brief. Again, if I were to say do show VLAN, you see how we end up with some additional information there, right? Okay, so we've got the VLANs created on switch 1. Let's go ahead and wash, rinse, and repeat here. We're going to jump onto switch 2, and we're going to do the same thing. So we're going to get into global config. We're going to say VLAN 10, name is faculty staff, VLAN 20, the name is students, VLAN 30, the name is guest or default, VLAN 99, and the name is management and native, and then VLAN 150 is going to be our voice VLAN. Oops, sorry. And we get one more opportunity here to exercise our VLAN configuration skills. We come over to switch 3, and we go from user exec into privilege exec with the enable command, and then into global config with the configure terminal command. And we say VLAN 10, name faculty staff, VLAN 20, name students, VLAN 30, name guest default, VLAN 99, name management and native, and then VLAN 150, name voice. Now, you're probably asking yourself, is there an easier way to do this so that I don't have to go to every single switch and create all of these VLANs? And the answer is absolutely 100% yes, there is an easier way to do this. And it's using the VLAN trunking protocol, or VTP, which I do believe we'll be covering in this course. But for right now, we want to make sure that we have down solid how to create VLANs, how to name the VLANs, and so this was a good opportunity to do that. All right, we're now on step number 4 in part 2, verify VLAN configuration. So again, I would say show VLAN brief, and I've got all the VLANs there for switch 3, and then we'll say show VLAN brief, and 10, 20, 30, 99, 150, we're good on switch 2. So here is where we're going to assign the VLANs to specific ports. Now we're going to assign VLANs to the active ports on switch 2, and you can see switch 2 has 3 active ports where PCs are connected. And you can see they actually give us those ports right there. So how do we do this? Well, let's get into global config, and I'll start with interface fast Ethernet 011. Now, it says that we're going to go ahead and make this a member of VLAN 10. So I would say switch port access VLAN 10. Now, the switch port mode access at this point is optional. However, it is a best practice to put this command on the port, right? To say switch port mode access. And it says, yeah, configure them as access ports and assign the VLANs. And so that's that, and the port is already up. And so then let's get into fast Ethernet 018, where we're going to say switch port mode access, switch port access VLAN, and this is 20. And then fast Ethernet 06, we're going to say switch port mode access, and then switch port access VLAN 30. Let me double check that. All right, so that looks good. Now, the next thing, do show interface. Let me see something here real quick. That's what I thought. All right, I'm curious to see how they play this out. All right, so we put these guys into their VLANs, and so it looks like spanning tree is working away. So now we're going to do the same thing on switch 3 for the hosts on this side. We're going to get into global, we're going to get into global config here, and we're going to say interface fast Ethernet 011, switch port mode access, switch port access to VLAN number 10. And then we're going to get into interface fast Ethernet 018, switch port mode access, switch port access VLAN 20. And then finally, interface fast Ethernet 06, where we're going to say switch port mode access, switch port access VLAN 30. And I'm looking to see if they have trunk ports being created somewhere here. All right, so now we get to step 3 of part 3, assign the voice VLAN to fast Ethernet 011 on switch 3. It says as shown in the topology, and here we are right here, as shown in the topology, we already did the VLAN 10 interface, but we need to add in on switch 3. Let's see what we've got here. Integrated 100 switch. Yep, on the phone. I'm just reading through here real quick. Okay, so the interface must be configured to support traffic to PC4 using VLAN 10. We did that with the switch port mode access and the switch port access VLAN 10. But we need to account for the voice traffic. And so how do we do that here on switch 3? Well, we're going to get an interface fast Ethernet 011, and you would say switch port and its voice, right? And if I do a question mark, you can see our options here. So switch port voice VLAN, and that VLAN is going to be 150. And so that's the command, switch port voice VLAN 150. And we should go from 86 points. We should see a couple points come out of this here. And yep, takes us to 90, right? So that was a 4-pointer. And then this last command as well, right? So it says enable QoS and trust the class of service, the COS, assigned by the phone, because the phone is going to be assigning class of service values, and we want to make sure that those are trusted. So I'm going to say MLS, QoS, and let me make sure I'm on target here, COS, and then actually, I'm sorry, trust COS. There it is. So it's MLS, QoS, trust, COS, and this should actually take us to 94, I would think. And let's see what happens here. And it did not. So let me continue to read. So verify loss of connectivity. So previously, PCs that shared the same network could ping each other successfully. Okay, good. So here we go. So they're walking us into this issue. And that's why I did that command earlier. I said, do show interface trunk. I didn't see anything saying create trunk links. And I'm like, what they just had us do right there, we've just lost connectivity. There's no way that anything on the left would be able to communicate with anything on the right, even if they're in the same VLAN. It simply would not work. and that's what I was looking to see if they had us do. I didn't see anything here, but I guess we're getting to that right now. So previously, these PCs were able to talk to each other. But now what happens when I say ping 172.17.30.26? So I'm on PC3, and PC3 is a member of VLAN 30. And I'm trying to ping PC6, who is also in VLAN 30. However, look at what's happening. We can't ping each other. And where that worked before, it now no longer functions. And then it said PC1, try PC1 to 4. It's the same thing. The pings, oh, okay, were they successful? I thought it said they were successful, but no, it's asking, were they successful? And the answer is no, they should not be successful. In fact, let me ping again. Let's make sure, 1024. So this should not work, right? And the reason that this is not going to work right now is that what do we have between the switches here? And let's change color and go back to red. So this port right here that connects to this port right here, and this port right here that connects to this port right here. What VLAN are those ports in right now? Yeah, they're all in VLAN 1, right? They're all in VLAN 1. So are any of these hosts in VLAN 1? And the answer is no. And the only traffic allowed to transit right now between these switches is VLAN 1 traffic, because that's the default. Now, if everything was in VLAN 10, all I would have to do is go to these ports and say, switch port mode access, switch port access VLAN 10. And then everything over here on the right in VLAN 10 could talk to everything over on the left in VLAN 10. Because at that point, VLAN 10 is on these ports, and the switches know how to handle that traffic. But we've got a different situation. Our situation is the following. We have 3 VLANs on this side, and we have 3 VLANs on this side. So we can't assign 3 separate VLANs or 3 individual VLANs to a single port. But what we can do is we can create a trunk port. And by default, the trunk port allows all VLANs to transit it, right? So in other words, all VLANs by default are allowed to transit a trunk link. And that's the question here. What could be done to resolve this issue? And I'm assuming that's where we're missing these 4 points. And my guess is it's going to be 1 point, 2 point, 3 points, and 4 points. That's just a guess, right? But I think I might be onto something here. So let's take a look. Let's go ahead and configure the gig ports between these switches as trunk ports. And that command that I ran earlier, if I was to say do show interface trunk, this is saying show me the interfaces on this switch that are trunk ports. And again, I was glancing ahead and I didn't see anything telling you to configure a trunk link. So then I was wondering, well, how are they going to get out of this and make this work as a packet tracer activity now that we've created these additional VLANs that are not on the link between the switches? And this is it, right? We've got to do a little troubleshooting here. So how do we fix this? Well, let's see if I'm on switch 2, and I can give myself a little more room there. And it looks like gig 01. So let's get an interface gigabit Ethernet 01. In fact, if I say do show switch port, is it interface switch port? I think it's interface switch port. Hold on one second. Do show, and let me get some context sensitive help here. It's show interface fast Ethernet 0 or gig, sorry, gigabit 01 switch port. That's what we want to see. So remember, this command is extremely helpful. Show interface, the interface, and then switch port. Shows me that it's enabled. The administrative mode is dynamic auto. However, what is the operational mode? It's static access. And this causes a lot of confusion for learners because they see that the dynamic trunking protocol is on because the administrative mode is dynamic auto. But then they see that it's an access port. And they say, well, wait a second. If dynamic trunking protocol is on, how in the world has this become an access port? And we haven't talked about DTP yet, but this is how it works. By default, on the newer Cisco switches, the administrative mode for dynamic trunking protocol for all ports will be dynamic auto. But here's what happens. If this side is auto and this side is auto, and again, that's the default, they will never form a trunk link. Ever, right? Now, there's another mode. It's called dynamic desirable. So if you have auto and auto, that is going to be no trunk port, no trunk. If you have auto and desirable, that will form a trunk. If you have desirable and desirable, that will form a trunk, right? But the default Cisco settings are dynamic auto, dynamic auto. So what happens here is when we plug these switches together, and the same thing is happening over here. I guarantee that this is going to show up as static access for the operational mode. So when the cable is plugged in between these two switches, the switch says, well, I'm dynamic auto mode. So if you want to form a trunk, then tell me you want to form a trunk. The problem is the other side is saying the same thing. So they're both saying to each other, hey, if you want to form a trunk, then tell me you want to form a trunk. But neither side is telling the other, hey, let's form a trunk. That's the dynamic desirable mode of DTP, right? So it's dynamic auto. So after the trunk or after the ports say, hey, I want to form a trunk, but only if you tell me we're going to be trunks, then they realize, well, you know what? It looks like nobody on the other end wants to be a trunk link with me. So I'm going to fall back to an access port. And in fact, it's an access port in VLAN 1, which is the default. So the default Cisco settings tend to cause some confusion. Because as soon as you see the link between switches, you say, oh, it's a trunk port. But it's not, right? It's a static access port right now. We would have to tell it that we want it to be a trunk port, and we can hard code it, right? And so if we hard code one side, the other side, right, and I'll say if we hard coded one side, then the other side can be dynamic or auto, and we're going to end up with a trunk. And so let's see what happens here. Let me clear the screen. We'll set that, and we'll get into global config, and we'll say interface gigabit Ethernet 01. I'll say switch port, mode, trunk. And you can see that it goes down, but then the interface comes right back up, and now it looks like we've got spanning tree in place. So now I'm going to do the same thing on switch 3. We're going to get into interface gigabit Ethernet 02. I'm going to say switch port, mode, trunk. Now, I'm not going to do any of the bells and whistles that come along with trunk links, and we'll let this play out. So now when I say do show interface trunk, we've still got some spanning tree action going on there. You can see over here that it's kind of sorted itself out, and let's see what ends up happening. Now, as you can see, this do show interface trunk command is very important. It shows me a lot of interesting information. It shows me my native VLAN is VLAN 1. It shows me that the status is trunking. The encapsulation is 802.1q. The mode, right? Was it dynamic auto? No. Is it dynamic desirable? No, it's on because I said switch port, mode, trunk. I hard coded it to turn on the trunking. Now, we've still got a little time here, but let's come back over to switch 2 and let's do the same thing. Do show interface trunk. And now we see what we're looking for, right? And this last output, this is probably the most important output right here, is VLANs in the spanning tree forwarding state and not pruned, which means the translation in English here is these are the VLANs that are going over the trunk port. And so typically the troubleshooting comes in when you have a host on VLAN 10 over here, and you can't communicate with this guy over here on VLAN 10. This command right here allows you to see, is VLAN 10 even being allowed over the trunk link? And you can come in and look right here. And again, VLANs in spanning tree forwarding state and not pruned. Pruned means they haven't been removed from the trunk link. And again, you can see the mode is on and everything looks good. But what about switch 1? I told you, and let's get into privilege exec here, show interface trunk. Remember I told you that I don't have to say switch port mode trunk on both sides, because as soon as I do it on one side, right, the other side, if it's auto, and remember, what is auto saying? Auto is sitting there saying, well, if you want to be a trunk link, you need to tell me we're going to be trunk links. And if you don't tell me we're going to be trunk links, then we're not going to be trunk links. And so again, when both sides are auto, they're both kind of saying that to each other, and then they never become trunk links. They default and fall back to access ports, and they'll be in VLAN 1. Now, on switch 2, I said switch port mode trunk. And so now switch 2 is saying, hey, let's be trunks, let's be trunks, let's be trunks. And switch 1 is saying, well, I want to be a trunk link, but only if you tell me, oh, hey, wait, I see that you're telling me you want to be a trunk link. I can do that. And so we have a negotiated, that's what that N stands for right there. It has negotiated the encapsulation of the trunk link, which is 802.1q. That's the industry standard. And it shows that the link is trunking and the native VLAN is 1, and maybe that's going to be our 4 points. I notice we don't have the 4 points yet. So I'm assuming VLAN 99 is what we're going to have to do here. And more importantly, what is in the forwarding state? So let's actually configure with what they're looking here. So I said interface, gigabit Ethernet 01. We already said switch port mode trunk. We hard coded it. We're going to say switch port trunk, native VLAN 99. And my guess is we're going to go to 91 out of 94 when I do that. No. Okay, well, this is interesting. It's got to be something else is going on. All right, now, you get this error here, right? And it says spanning tree received, VLAN ID error, BPDU, inconsistent peer, VLAN ID 1. In other words, we're going to see any second now, we should see another error come up. And another syslog message is going to come up. And it's going to say native VLAN mismatch. And this is very, very common because we just changed the native VLAN. Remember, the purpose of the native VLAN is if switch 2, and there we go, right on cue, native VLAN mismatch, right, from the Cisco Discovery Protocol. So if switch 2, let's say, had a hub connected here, and there were some PCs hanging off of the hub, and you don't see this anymore. Hubs really aren't used at all. But if there was a hub here, the hub, it's not a trunk link when it's a hub, right? So the hub would plug in, and that traffic could be unlabeled. In other words, the traffic doesn't have a VLAN tag. So when it hits the trunk port's going to say, I see that you don't have a VLAN tag, therefore I'm going to apply the native VLAN tag, which would be 99, right? So untagged traffic that's trying to transit across a trunk link that doesn't have a VLAN tag will get the native VLAN tag. All right, so we did that, and then let's go ahead and say, I'll say switch port, no negotiate. We'll turn off DTP, and I'm wondering what it is that they're looking for to give us these points. Okay, so do show run. Let's take a look at gig 01. And there is gigabit Ethernet 01, so switch port trunk, native VLAN 99, switch port mode trunk, and switch port no negotiate. Let's do the same thing on switch 1. So we're going to get into interface gigabit, and actually we're going to get into global config first, interface gigabit Ethernet 01, switch port mode trunk, switch port trunk native VLAN, VLAN 99. And that's, I'm just abbreviating it because you can really abbreviate some of these commands. And then I'm going to say switch port no negotiate. All right, so that is our trunk port there, interface gigabit Ethernet 02, switch port mode. You could literally say switch port mode trunk, switch port trunk native VLAN 99. That's how short you can make these commands. And you can see we got the little blocking over here, right? That spanning tree says, whoa, wait a minute. The VLANs on either end of this trunk link don't match. That is a problem. And then that's it for switch 1. We'll come over to switch 3, and I don't even need to look at the diagram because I can see the error message telling me interface gigabit Ethernet 02, and we'll say switch port mode trunk, switch port trunk native VLAN 99, and again, the inconsistency has been fixed, and then switch port no negotiate. All right, do show run, and let's check it out, and everything looks good, right? So now, let's run those ping commands again. So can I ping PC4 who's in the same VLAN that I'm in? And the answer is absolutely, because here's what happens. The traffic comes this way, it hits switch 2, and switch 2 says, yeah, this is a trunk link, and I'll, by default, allow all VLANs to transit that trunk link, and then it finds its way over to PC4. Let's come to PC2. And let's take a look at PC2 here, and let's ping 172.17.20.25. And we've got connectivity there. And finally, PC3, it looks like we tried here earlier, and now it works. So let me take a look. I must have read right by something here because we are short 4 points. And let's check results. Let's see what I may have missed. Ah, okay. VLAN 99 as the native VLAN. So it looks like on switch 1, and I could have swore that we did that on switch 1. Let's close this out here. We created them on lots of the switches. Let's pull switch 1 back up. And did I maybe misspell the name or something like that? Let's take a look. So how do we see the VLANs? Show VLAN brief. And there is VLAN 99 managed. Did I misspell management? Is that what it's getting me on here? Let me see this really quick. Where are the names? And I did misspell management. I'm wondering if, did it really withhold 4 points because I misspelled management? Let's get into global config. We're going to say VLAN 99, name is management and native. All right, very picky. And does that get, and wow, all right, that was it. Holy Toledo. Okay, so this is going to wrap up packet tracer activity 6.2.1.7, and we saw that spelling counts here, right? So got to be precise when dealing with packet tracer. So this is going to wrap up the activity 6.2.1.7. Remember, some of the key takeaways that we discussed is that when multiple VLANs need to transit the link between switches, it's going to have to be a trunk link. By default, those links are in VLAN 1. By default, it's dynamic auto, which means they're not going to form the trunk link. We're going to have to give them a little help and help it along, right? All right, well, that is it for this activity. I thank you guys for watching. Hopefully this has clarified any of the questions you might have had with VLANs or how to solve this. And that's it. I will talk with you guys soon.